Hey guys, I hope you're doing well. I hope you watched the slideshow and took the notes and did the afterschoolhelp.com video yesterday on 8.5. I hope that was all helpful. I made a note that we weren't going to do the graphing portion of this lesson at all. So if you didn't catch that in looking at my notes, yes, there is a graph, but we are not doing the graphing portion. We're going to skip that. But you do have to know how to convert logs, and this is kind of cool. And so I'm going to go through the exponential and the logarithmic with you. This is something brand new, other than you taking the notes yesterday. But a log is rewritten of an exponential. Okay, so you have a log function. Y is equal to log base b of x if, and only if, x is equal to b to the y. So you rewrite things, you change things around. Couple key things to note here is your b value. Your b value is always your base. B is your base value. No matter whether it's the log value or the base of the exponent, the b value is always your base value. All right, so that's key. So I wanted you to look at your worksheet that I've assigned for today for the practice. And I'm just going to do a couple of them with you and just kind of show you what I'm talking about. So the first one is log base 7 of 49 is equal to 2. And that's 100% true. And that's how it's written. But the reason it's true is because of its exponential equivalent. The exponential equivalent says that 7 to the second power is equal to 49. And so you use that same base. Base of 7 is the base of the exponent. 7 raised to the second power is 49. And so that makes that a true statement. Let's look at number 2. Log base 14 of 196 is equal to 2. Well, is that a true statement? It is, because 14 raised to the second power is 196. So hopefully that'll go pretty quickly. All you're doing is writing from the log form. You're writing this exponential form. That's all you have to do on 1 through 6, and I just did 1 and 2 for you. All right, so let's jump down to the second half of the page, number 7. You're now supposed to evaluate each expression. This expression is log base 6 of 36, and that's all they give you. So notice something's missing. The equal something is missing. So we really just kind of put that in as a placeholder, and we know that every time we have a placeholder, we can make a variable out of it. So log base 6 of 36 equals what? A variable. Then when you rewrite it into exponential form, you have 6 to the x power is equal to 36. Well, and we know that that's going to be squared, but why is it squared? It's squared because 6 to the x power equals, and remember how we took these numbers and we put them in their base form? That's 6 squared. 36 is the same as 6 squared. So if our bases match, our exponents have to match. So our missing value is a 2. That entire process has been evaluated. So log base 6 of 36 equals 2 because 6 squared equals 36. Okay, I want to do one more with you. I'm going to try to squeeze it in down here. All right, so I'm going to do number 8. And the reason I'm going to do number 8 is because it's got a fraction in there and it'll freak some of you out. All right, so here we go. Log base 6 of 136. 1 over 36. Okay, so when you look at this, you still have a base of 6. You still have the of number, and we're still missing something. Missing a number. So that means that 6 to some power is equal to 1 over 36. Well, we discussed over here that 36 was the same as 6 squared. So this means that 6 to the some power is equal to 1 over 6 squared. Well, how do we get that 6 squared in the denominator? How do we get a 2 in the denominator? Well, if it were negative exponent to start, it becomes 1 over. So our missing number for this guy is a negative 2 because we had that fraction in there. So anytime you see something like a fraction, you get a negative power. All right, guys, I'm out of paper. I hope that this has gone well for you. My phone is ringing. I'm going to have to get that. And I will talk to y'all soon. Bye.